Hello everyone, welcome to Math Archives. This is Subhashini Vijaysegaran, a Maths teacher. In this video, I am going to explain the entire concept of covariance and correlation in detail. In practical, we have to face a large number of problems involving two or more than two variables. For example, let me take the simultaneous study of height and weight of students in a college. Here, we are interested to know if there exists any relationship between these two variables and a study. If so, again we would like to know how far these two variables are related with each other. Like this, most of the variables show some kind of relationship between them. For example, there exists some relationship between age of husband and wife, and price and supply of a product, like that, income of a person and his expenditure, etc. With this short introduction, let me now move on to the topic with the three big questions. Since we are dealing with the distributions only with two variables, my first question is there any relationship between the variables and a study? If so, then how to measure the relationship between the variables? Then, after measuring, we would like to know what is the strength of relationship between the variables and how to measure it. Let me first explain the first question. How to identify or determine the relationship between the variables? Let me take as an example temperature and sale of ice cream. Here, temperature and sale of ice creams are two different variables. If temperature increases, definitely the sales of ice cream increase. Like that, if temperature decreases, the sale of ice cream decrease as well. Here both the variables move in the same direction. Here the temperature is related to sale of ice cream. So there exists some kind of relationship between temperature and sale of ice cream, isn't it? Then price and supply. If supply increases, price decrease. Like that, if supply decreases, definitely the price will increase. Here both the variables move in the opposite direction. Even though they are moved in opposite direction, that is one of them increase, the other will decrease. But supply is related to price. Yes, there is some kind of relationship between supply and price, isn't it? Then, let's move on to third example. Salary of a school teacher and rainfall in India. There exists no relationship between the salary of a teacher and rainfall in India. So, there is no relationship. It is meaningless. That is, comparing the two variables to find is there any relationship between them is meaningless. There exists no relationship. So now you got clear idea about how to find is there any relationship between the variables and our study? Now, you got a clear idea about how to find the existence of relationship between the variables under our study. Then we move on to our second question. Suppose if there exists a relationship between the variables, our next step is we have to measure the relationship. Then how to measure the relationship between the variables? For that, we make use of the concept of covariance. Let me have a brief discussion over covariance and come back to the third question. Covariance. When you break down the word covariance, that is co and variance. Co meaning together. Variance refers to variation or change. That is, covariance measures how much the two variables change together. That is, in short, covariance tells is there any relationship between the two variables? If so, and what is the direction of the relationship between the two variables? So, covariance is used to find out the direction of relationship between the two variables. Since we are dealing with variables, so you should have knowledge over when we say the variables are positively related or negatively related to each other. Variables are positively related if they move in the same direction. Here I have to take economic growth and stock market return as two variables. If economic growth increases, definitely the stock market return increase. Like that, if economic growth decrease, the stock market return decrease as well. Here both of them travel in the same direction. So here the two variables, economic growth and stock market returns, are positively related since they move in the same direction. Like that, variables are negatively or inversely related if they move in the opposite direction. For example, let me take the oil production and gasoline price. If oil production increase, definitely the gasoline price decrease. On the other hand, if the oil production decrease, definitely the gasoline price increase. Here both of the variables travel here or move in opposite direction. If so, then we say the two variables, oil production and gasoline price, are negatively or inversely related to each other. But to determine the actual relationship between the variables, we have to make use of the formula of covariance. Covariance is an absolute measure. It is covariance of x comma y is equal to 1 over n, sigma I varies from 1 to n, the product of xi minus x bar and yi minus y bar. Here I have to list out some of the points which you have to remember when we are dealing with the concept of covariance. Covariance can take any value between minus infinity to plus infinity. It can take any value. Here negative value is an indicator of negative relationship and positive value is an indicator of positive relationship. Based on the sign, we can identify the direction of relationship, whether it may be positive or negative. If the value of covariance is 0, then there exists no relationship between the two variables. That is, covariance is 0 means the two variables are not related. That is, there exists no relationship. Covariance is measured in units. Actually, the unit of covariance is obtained by multiplying the units of the two variables. Covariance is affected by change in scale. Suppose if you multiply all the values of one variable by a constant and you multiply the all value of other value by the same or different constant, then the value of covariance is changed. So it is affected by change in scale, but it is unaffected by change in location. Let me now move on to an example and find out the value of covariance. Here the two variables x and y is given. The formula for calculating covariance is covariance between x comma y is obtained by make use of the formula 1 over n, sigma I varies from 1 to n, xi minus x bar into yi minus y bar. For that, let me now construct a table whereas the first and the second column consist of the values of x and y. Now, I have to first find out the values of x bar and y bar. For that, I make use of the formula x bar is obtained by dividing sum of all values of x by n, and y bar is obtained by dividing sum of all values of y by n. If I add all values of x, you get sigma x. 3 plus 4 7 plus 5 12 plus 6 18 plus 7 25. So that is equal to 25 over the total number of values of x 1 2 3 4 5. So x bar is equal to 5. And then next y bar. For that, let me first add all values of y. 8 plus 7, 15 plus 6, 21 plus 5, 26 plus 4, that is 30. So 30 by 5, so you get 6. So x bar is equal to 5 and y bar equal to 6. So now let me calculate x minus x bar first, and then y minus y bar, and then let me take a product of these two, that is x minus x bar and y minus y bar. Here x minus x bar, the value of x bar here is 5, and y minus y bar here is, y bar value is 6. Now subtract all values of x from 5, that is 3 minus 5 minus 2, 4 minus 5 minus 1, 5 minus 5 0, 6 minus 5 1, 7 minus 5 2. Like that, subtract all values of y from 6. 8 minus 6 2, 7 minus 6 1, 6 minus 6 0, 5 minus 6 minus 1, 4 minus 6 minus 2. And now let me make a product of these two, that is minus 2 as multiplied with 2 we get minus 4, minus 1 with 1 we get minus 1, 0, minus 1 and minus 4. If you add all these values, you get the total as minus 10. So covariance between the two variables x comma y is calculated by 1 over n, total number of values 5, the sum of all values of this product is minus 10, that is equal to minus 2. So covariance of x and y for this problem is minus 2. Here negative value is an indicator of negative relationship between the variables and 2 is the magnitude of covariance. So this is an example of how the variables are inversely related to each other, that is there exists a negative relationship. Let me discuss one more problem under this category. Calculate covariance. Here the values of x and y is given. We know the formula for calculating covariance between x and y is covariance of x comma y is equal to 1 over n, sigma I varies from 1 to n, xi minus x bar into yi minus y bar. For that, let me now construct a table, whereas the first and second column consist of the values of x and y. So to calculate the covariance, first let me calculate the values of x bar and y bar first. That is arithmetic mean of x bar, that is sigma x over n, and y bar is equal to sigma y over n. Now if we add all values of x, we get 15 plus 18 plus 25 plus 27 plus 30 plus 35, we get the total as 150. That is sum of all values here is 150. So x bar is equal to 150 over the total number of values of x is 1, 2, 3, 4, 5, 6. Totally there are 6 values. If you divide this by 6, you get 25. Like that, if you add all values of y, 50 plus 65 plus 82 plus 95 plus 110 plus 120. We get the total as 522. And when we divide by the number of values of y, 1, 2, 3, 4, 5, 6, here itself we have 6, and divide this by 6, we get 87. So now x minus x bar, and we calculate y minus y bar, and we make a product of x minus x bar and y minus y bar. The value of x bar here is x minus 25 and value of y bar is 87. Now we have to subtract all values of x from 25. 15 minus 25 minus 10, 18 minus 25 minus 7, 25 minus 25 0, 27 minus 25 plus 2, 30 minus 25 5, 35 minus 25 10, and y minus y bar. Now we have to subtract all values of y from 87. 50 minus 87, that is minus 37. 65 minus 87, that is minus 22. 82 minus 87 minus 5. 95 minus 87 plus 8. 110 minus 87, we get 23. 120 minus 87, 33. Now we have to multiply x minus x bar with y minus y bar. So minus minus becomes plus. So we have 37 is multiplied with 10, we get 370. And 7 multiplied with 22, we get 154. 0 with any number 0. 2 8s are 16. 5 multiplied with 23, we get 115. And 33 is multiplied with 10, we get 330. If you add all values, we get 370 plus 154 plus 16 plus 115 plus 330, we get the total as 985. So 1 over the total number of values here 6, 985. When you divide this by 6, when we divide 985 by 6, we get 164.166. That is, I have to take 164.17. Is equal to 164.17. So, covariance between x and y is 164.17. Here that is a plus sign. So here, based on the covariance, here we have to understand there exists a positive relationship exists between the variables x and y. And 164.17 is nothing but magnitude. From these two problems which we have discussed now, it is clear that using covariance we can only find the direction of relationship between the two variables. We just know only the direction. Either they are positively related or negatively related. That is, there exists a positive relation or negative relation between the two variables. Also, it doesn't give any information about the strength of relationship between the two variables. Strength in the means how the two variables are closely related to each other. That is, how much closely they are related to each other, we doesn't know using the concept of covariance. Since the value of covariance takes the values from minus infinity to plus infinity, we doesn't get any information about the strength of the relationship between the two variables. We just only know the direction of the relationship between the two variables only. So, if we would like to know the strength of the relationship between the two variables, we make use of the concept of correlation. So now let's have a brief discussion over correlation and let's come to a conclusion. Like covariance, correlation is also a measure of how the two variables are related to each other. But it moves one step forward than covariance and gives us information about both the direction and strength of the relationship. Covariance gives only the information about the direction of relationship between the two variables. But correlation gives us the information about both the direction and strength of the relationship between the two variables. Here the strength in the sense that how much closely the two variables are related to each other. Correlation is the degree of association between the variables. The two variables are said to be correlated if the change in one variable results in a corresponding change in the other variable. Then only we said the two variables are correlated to each other. So correlation is of two types, positive correlation and negative correlation. If the variables move together in the same direction, then we said there exists a positive correlation between them. For example, income and consumption. If income increases, definitely the consumption increases. If the income decreases, definitely the consumption also decreases. Here, both of the variables move together in the same direction. It's a positive correlation between income and consumption since they move together in the same direction. Negative correlation. The variables move together in the opposite direction. Then we said there exists a negative correlation between them. For example, let me take here price and demand. If the price increases, definitely the demand decreases. On the other hand, if the price decreases, the demand will automatically increase. There exists a negative correlation between price and demand since both of the variables move together in the opposite direction. Correlation coefficient. It's one of the very important measure. Based on this alone, we can identify the strength. We can find out the strength of the relationship between the two variables. So it is a numerical measure of correlation. The coefficient of correlation between the two variables are generally denoted by the letter R by rho. So R is equal to covariance of x comma y over the standard deviation of the product of x and y. So the value of correlation coefficient are always between -1 and +1. Based on the value of R, we can identify what is the relationship between the two variables. That is, how strong the relationship between them. Based on the value of R only, we can identify. Is there exist a strong relationship or weak relationship? Based on the value of R, we can identify and we should say the two variables are closely related or not. If R is equal to +1, there exists a perfect positive correlation between them. If R is equal to -1, there exists a perfect negative correlation. If R is equal to 0, there exists no correlation between the variables. If R takes the value 0 to 0.5 except 0 and 0.5, then there exists a low positive correlation. If R takes the value 0.5 to 1 except 1 here, if it is like this, then there exists a high positive correlation. Likewise for the other hand too. If it is from 0 to 0.5, that is low negative correlation. If it is from 0.5 including 0.5 up to -1 but except -1, means that exists a high negative correlation. So based on the value of R, we can identify or we should know the strength of relationship between the two variables. That is, how far the two variables are closely related to each other. That's based on the value of R we can identify. So correlation coefficients are used to measure the strength of the relationship between the two variables. Also, it gives us information about both the magnitude and direction of relationship between the two variables. So based on the correlation coefficient, we should know, or based on the correlation coefficient, we can get an information about the magnitude and direction of relationship. For example, plus 0.825. Here, plus, that indicates the direction. And 0.825, that is the magnitude. Based on this value, I should say if it is 0.8, look at the chart once again. If it is 0.8, approximately it is here. If it is here, there is a high positive correlation. So based on this value, I should understand there exists a high positive correlation between the two variables. Look at this. Negative value is an indicator of negative relationship, 0.347. Look at the chart once again. If it is minus 0.3, approximately here, that means there exists low negative correlation. So if it is minus 0.347, I can understand there exists a low negative correlation between the two variables. Here I have to list out some of the points which you have to remember while we are going to deal with the concept of correlation. Correlation can take any value from minus 1 to plus 1. If the value of correlation is 0, then there exists no relationship between the two variables. It's a unit-free measure. Correlation doesn't have any unit. It is not affected by change in scale and also change in location. Let me take the same problem that we have discussed under covariance. Find correlation for the following data. The formula for calculating correlation is R is equal to covariance of x comma y over standard deviation of x into standard deviation of y. And also the formula for calculating standard deviation of x is square root of x minus x bar the whole square by n, and standard deviation of y is equal to square root of y minus y bar whole square by n. Already we calculated the value of covariance x bar and y bar, and just make use of those values. Here the covariance is minus 2, x bar 5 and y bar 6. I make use of these values. So now covariance between the two variables is minus 2, x bar is 5 and y bar is 6. Now let me construct a table. Consists of the values of x and y. For calculating the standard deviation of x, first I have to calculate x minus x bar. So that is x minus x bar. Then I have to take the square of that value. So here x bar is 5. So if you subtract all values of x minus 5, we get 3 minus 5, minus 2, 4 minus 5, minus 1, 0, here 1 and 2. When we square these values, here we get 4, 1, 0, 1, 4. And the total of all these values is 4 plus 1 plus 1 plus 4, that is 10. So that is equal to square root of 10 over total number of values here 5, that is square root of 2. Like that, I have to add Like that, I have to calculate the value of y minus y bar first. Here y bar is 6 and then I have to make the square of that value. So now subtract all values of y minus 6. We get 8 minus 6 2, 7 minus 6 1, 6 minus 6 0, 5 minus 6 minus 1, 4 minus 6 minus 2. When we square these values, we get 4, 1 square 1, 0, minus 1 square plus 1, minus 2 square plus 4. By adding all these values, you get the total as 10. That is 10 by 5. Square root of 10 by 5 is root 2. So here we get standard deviation of both x and y as root 2. So r is equal to covariance is minus 2 over root 2 into root 2. That is root 2 into root 2 is nothing but 2 itself, minus 2 by 2 is minus 1. So correlation is minus 1. So look at the value of r. Based on the value of r, we can get an information about the strength of relationship and also the direction of relationship. Here negative value is an indicator of there exists a negative relationship between the two variables x and y. That is, there exists a negative correlation between x and y. Both of the variables are inversely related to each other. That means one of them increasing means other one decreasing as well. Here 1 represent there exists a perfect negative correlation. Here there is a minus. So based on this value, if r is equal to 1, as I said already, if r takes the value minus 1, that means there exists a negative correlation. That is perfect negative correlation between the two variables. Let me discuss one more problem under correlation. Calculate correlation. Here the two variables x and y is given. The formula for calculating correlation is r is equal to covariance between x and y over standard deviation of x into standard deviation of y. To calculate the standard deviation of x, we make use of the formula square root of x minus x bar the whole square over n. And to calculate standard deviation of y, we make use of the formula y minus y bar the whole square over n. Already we calculated the covariance x bar y bar. Because we have discussed the same problem under covariance, I have to take those values here. Make use of those values here. Here the value of covariance is 164.17 and x bar is 25, y bar is 87. So we make use of the three values, that is covariance between x and y is 164.17 and x bar value is 25 and y bar is 87. Now, to calculate standard deviation of x and y, we make use of. Now, to calculate the standard deviation of x and y, let me construct a table whereas the first and fourth column consist of the values of x and y. Let me now first calculate x minus x bar and x minus x bar the whole square. Here the value of x bar is 25. So I have to subtract all the values of x minus 25. 15 minus 25 minus 10. 18 minus 25 minus 7. 25 minus 25 0. 27 minus 25 2. 30 minus 25 5. 35 minus 25 10. When you square these values, minus 10 square is nothing but 100. Minus 7 square 49, 0, 2 square 4, 5 square of 5 25 and the square of 10 100. If you add all these values, we get 9 plus 4, 13 plus 5, 18. Remaining we get 1, 3 plus 4, 7, 278. So this is equal to square root of 278 over n is number of values of x. How many number of observations are there? 1, 2, 3, 4, 5, 6. Totally 6. So this is equal to, when we divide 278 by 6, we get 46.33. If we take the square of this value, we get 6.807. I have to take up to 3 decimal places, so 6.807. So that's equal to 6.807. Now let me calculate the standard deviation of y next. For that, first let me calculate y minus y bar. So y minus y bar, and we need y minus y bar the whole square. So y minus y bar is 87. So subtract all values of y minus 87. 50 minus 87 minus 37. 65 minus 87 minus 22. 82 minus 87 minus 5. 95 minus 87 plus 8. 110 minus 87, 23. 120 minus 87, 33. And we square these values, we get 37 into 37. That is 37 square. 1369. And 22 into 22 we get 484. That is square of 28 to us 484. And 5 square 25, 8 square 64, then 23, the square of 23 is 529, and the square of 33 is 1089. When we add all these values, we get 1369 plus 484 plus 25 plus 64 plus 529 plus 1089. So we get the total as 3560. So now we calculate the value of y, sigma y, that is square root of y minus y bar the whole square is 3560 over number of values of y, that is number of observations. So totally we are having 6. So when we divide this by 6, we get 593.33. 593.33 over 6. So that's equal to, if I take the square of that value, I get 24.358. So 24.358. So now the covariance is, already we calculated 164.17. So now we got all the values. So let me calculate the correlation. So R is equal to covariance between x and y over standard deviation of x and standard deviation of y. So the covariance is 164.17 and the standard deviation is 6.807 multiplied with 24.358. So when you multiply 6.807 with 24.358. We get 165.805. The numerator we get 164.17. So when we divide 164.17 by 165.805, I get the value as 0.99. So that is equal to 0.99. So the value of covariance, the value of correlation is plus 0.99. So based on this, I come to a conclusion that there exists a positive, that is high positive correlation between the two variables. High positive correlation. There exists a high positive correlation because R value is 0.99. If R is between 0.5 to 1, there exists a high positive correlation. Here there is an indicator of plus sign. So that is the direction of relationship between the two variables. So there exists a high positive correlation between the two variables. Now let me compare covariance and correlation. I have to take these two examples which we have discussed before under covariance and correlation. I am just give you the graphical visualization of these two, and based on this you will get some idea about the direction of relationship, how the variables are moving together. So now let me compare the covariance and correlation. For that let me take the two examples which we have discussed under covariance and correlation. We just plot the points of x and y in a graph. For the first one 3, 8, the second point 4, 7, I'm just plotted here, then 5, 6, 6, 5 and 7, 4. So here the direction of movement of these two variables is from upward direction to the downward direction. So this means there exists a negative relationship between the two variables. So based on this scatter plot, we just get an idea about the direction of relationship, but to determine the actual relationship between these two variables, we go for the formula for calculation of covariance and correlation. So from this graph itself, it gives an idea about there exists a negative relationship. For this, let's come to the second one, 15, 50. If I plot this point in a graph, so there is a point approximately here, and 1865, the second point, like that. Here, there exists a upward movement. That means there exists a positive correlation between the two variables. Here the points are, that is the variables here are increasing. Since we are dealing with a linear relationship between the variables, if you draw a line, here all the points lying on a line, here all of them should lie on the line except 1 or 2. I'll just show you in a different graph. Yes. So here all the points lying in the same line. Here there must be some deviation of points from the lines. Okay. So here r is equal to -1. In this problem we calculate the value of r as -1. And for this problem you calculate the value of r as plus 0.99. So now understand why there is a deviation, because there will be r equal to plus 0.99 means there will be slight deviation. If r is equal to plus 1 or minus 1 means there exists a perfect relationship, either in upward direction or downward direction, that is positive relationship or negative relationship. So all of them should lie here in a line, since we are dealing with linear relationship. Okay. most probably we have to deal the concept of covariance and correlation in a linear case. And for this problem, covariance value is -2, and for this one, covariance of xy is 164.17. So look at these two. So based on covariance, so both of them gives you the negative sign. That means that indicates the direction of the relationship between the two variables. But here, based on the covariance value -2, we didn't get any information about the strength of relationship between the two variables. Whereas correlation coefficient gives you the value -1, that indicates there exists a perfect negative correlation between the two variables. And also look at here, both of them are positive sign. That means there exists a positive relationship between the two variables. And based on the covariance value, we didn't get any information about the strength of relationship between the two variables. That is how much closely the two variables are related to each other, that we don't know. But based on the correlation coefficient value, that is we get 0.99. So we should say there exists a high positive correlation between the two variables. So comparing these two, covariance gives only the direction of relationship, whereas the correlation gives both the direction and strength of relationship between the two variables. Before let's come to a conclusion, let us have a short revision over covariance and correlation. So covariance measure the direction of relationship between the variables, whereas correlation measures both the direction and strength of relationship between the variables. Whereas the value of covariance lies between -infinity to infinity, but the value of correlation lies between -1 to +1. Also, covariance is affected by change in scale, but the correlation is not affected by change in scale. Besides that, covariance is measured in units, but correlation is a unit-free measure. It doesn't have any unit. If the value of covariance is 0, then there exists no relationship between the two variables. Similar is the case here. When correlation value is 0 means there exists no relationship. And also covariance is unaffected by change in location. Similar is the case for correlation. So these two are the similarities between two variables. So there exists similarities between covariance and correlation in these two cases. Now let's come to a conclusion. Which is a better measure? So based on the discussion, correlation is unaffected by change in scale and location, and also it is used to make a comparison between two pairs of variables. It's a very important thing. So that I have to prefer correlation is better than covariance. Since covariance is a computational stepping stone for correlation, but correlation is preferred over covariance because of these reasons. Hope you got a clear idea about covariance and correlation. Thanks for watching. See you again in my next video.